In this video, I'll show you how a DAB converter works by looking at the waveforms. So this probably doesn't make sense now, but you will understand it at the end of this video. So first we have the half bridge, which goes from VI, which is 400 volts DC, into V1. And then we have the output voltage, which is 50 volts DC. So let's start at the beginning. First, we're going to look at the primary bridge, which is a full bridge. Now, the MOSFETs inside the bridge has mainly two operating points. So either S1 could be on or S2 could be on. So when S1 is on, the current will flow like this. So now the voltage V1 would be equal to VI because there is just a wire going like this. And then we have this point, right? And for the other half cycle, we have that S2 is on and S1 is off. So the current will go like this. And you can see that it's the opposite, so we get minus 400. And if we just think in the same way, we can do the same for the secondary side. Normally, the voltage goes from V2 to V out. But if we just flip it, we could say that it goes from V out to V2. And then we have the same principle as for the primary bridge. So we get that V1 goes from minus 50 to 50. And you can see here that there's this phase shift between V1 and V2, and now we'll go back to that later. Now we have the transformer, which just scales the voltage. So you can see that VP is equal to the turn ratio multiplied by V2. So if you multiply 50 with 8, you will get this waveform, which is 400 to minus 400. And now I want to look at the inductor. In order to find the voltage over the inductor, we need to look at the voltage difference, which is V1 minus VP. So this is the voltages on top of each other. So you can see that V1 minus VP would become this waveform. And in the middle here, the voltage is 0. So it goes from 800 to minus 800. And in order to find the current going through the inductor, we use this equation, which says that the change of current is proportional to the voltage over the inductor. So when the inductor voltage is equal to 0, the inductor current stays flat. But when it's negative, it decreases, and when it's flat again, it stays flat. And when it's positive, it increases. And this is only the first cycle, so it just continues like this. So you can now see that these are the waveforms that I just went through. So V1 is here, it's on the primary bridge, and then VP is here on the left side of the transformer, and then VL is the voltage over the inductor, and IL is the current going through the inductor. So one assumption that we made was that V out was constant and equal to 50. But that is not always true. The output voltage is dependent on the current in the inductor and also the voltage coming from here. Because we can actually calculate the output voltage by using the power balance. Because the power here needs to be equal to the power here, assuming that we have no losses, and this is on average. Output power is given by this, which is given by the output voltage. So because V1 is constant, IL is the one deciding the output power as well. So the larger IL, the larger output power, and therefore the larger V out. Now, if we increase the phase shift between the primary bridge and the secondary bridge, we will get something like this. This is with a phase shift equal to 180 degrees. And you can see that the voltage over the inductor here is equal to this. Now it's never 0. So it goes from minus 800 to 800. And this leads to an even larger current, as you see here. And therefore, we also have a larger output voltage because of the power balance. And now if there was no phase shift, you would see that the inductor voltage would always be 0 because V1 would be equal to VP. And therefore, we will have no power here because the current or the voltage over here, I forgot to explain that. So the voltage would be equal to 0 all the time. And therefore, the current will also be equal to 0 all the time. So we will have no power here, which means that we also have no power here. By controlling the phase shift, we can actually control the output voltage. And that is kind of like how a DAP converter works.